thank you so much for organizing this, Hero. And as Hero said, we have collaborated together for at least 20 years, for quite some time, and many good collaborations, and with a lot of patterns as well,
Yes.
and a lot of architecture and design security, and a lot of other areas. And I was coming to an event organized by Hero, coming up on doing some pattern mining of some AI practices, and we even have an event next week, which I'll talk about too, with this next week. And as Hero had pointed out, and I'm not sure if the camera is showing this, but I did bring a copy of my a physical copy of my new book, and I'm it's got 76 patterns is in this book, and there's a few pattern languages, and I want to spend some time going over it. When Hero had asked me, he encouraged me. So since I was coming for this AI event and we're doing some pattern mining, I'm working with that as well in collaborating with Hero. He invited me to come and give a talk about the release of our new book that we did have out there just recently. So basically, I'm going to cover this book. By the way, there's a QR code. You can get it either on Amazon or you can also get it through O'Reilly. It's off the O'Reilly platform. I know some people have access to the O'Reilly platform through their work or whatever, and everything's available there. I was hoping to have a few copies here. I think they're going to still show up by next week, but I had O'Reilly send a few copies here. Right now, it's only in English, but we do expect it to do some translation at some point to other languages such as Japanese. I've already had a few friends here that has worked with O'Reilly before that's talked about that. So hopefully we can do that, and maybe AI can help some too, right? Who knows? But there's still a lot of with translations. There's still a lot of challenges, and you need somebody that understands those types of things. So I'm going to and by the way, I've had, like I said, I've had a long collaboration with Hero, especially with patterns, and so I'm looking forward to some future collaborations with some of this as we go. And as Hero had said when he was introducing me, is I'm going to be talking about patterns. This book is really, I at least want to at least give a brief explanation so you at least know what I'm thinking when I say patterns. Because a lot of people, there's a lot of these different ideas of what a pattern is or what a pattern isn't, or like that. But a lot of times, to me, the simplest view is patterns are these repeated type practices. So if you have regular type practices that are useful and you're repeating them, and they prove useful for you can think of proven solutions to repeating problems, or maybe even proven practices to repeating situations. So maybe I'm designing a new GUI. That's maybe not a problem. I'm trying to design something new. But a lot of us in the pattern community, we always looked at it as a context. Within a certain context, maybe I'm developing a banking system with credit card, and I have some kind of security type issues. And the problem is how do I ensure that you're able to do the transaction, but nobody gets access to your information? And maybe there's some good solutions on how we encrypt the data and things like that. And so patterns are a way of codifying or capturing the knowledge of experts. And there's always trade-offs on designing anything complex. And so there's some positive sides of applying a pattern, but there's also the challenges that go with it. Sometimes they're called negative consequences. I'd like the term challenges a little bit better with that, because it's not necessarily negative. It's just, there's always when you do this, you might get some benefits, but there's also some costs associated with it. And patterns usually embody the experience of what works, and these recurring type problems come up. And so our book is based upon some patterns. We could have written, just like even if you look at Eric Evans' book on domain-driven design, a lot of people don't realize that was a patterns book, and it was at the patterns conferences in the early, we reviewed it, Ralph Johnson, Martin Fowler, Kent Beck, and other people. We were reviewing the book together with that. And it's a pattern book, but when you read it, it wasn't really written with the pattern form. We did use kind of a modified version of Alexander style patterns. And I'll show you a little bit about that. But it's really just trying to talk about with given the different contexts and with these different types of problems and these forces, how to solve that. And now our book has a lot of chapters. There's a lot of pages in this book. You know, I mean, it took a lot of work. There's over 600 pages in this book. That's it. That's definitely a lot of things. And actually, when we were first starting to write this book, we were already had been writing a lot of successes and challenges, some patterns at some different conferences about doing microservices, or how do you do design, or how do you do cloud native or cloud storage, or how do you modernize or your architecture or migrate to the cloud, or if you have a monolith and your organization's changing a lot, you want to move it to microservices. So we started this collaboration based upon some work we did pre-pandemic, but around pandemic time, 2020, 2021, we decided to write this book. And we actually had a lot of other chapters that we were going to originally do, such as DevOps and security and all these other things, but then that would have turned it to like 1,000-page book. So that was one of our challenges, is to get the focus about it. But what you'll see in this book with 70 some patterns, over 70 patterns, 70 core patterns, and then we also wrote 6 supporting patterns within that, is it really talks about what is architecture and with a cloud architecture, there's some different variations of things you can do and how to look at it at a high level. And then as you're developing for the cloud, there's some patterns on whether you're doing cloud native, and then plus something I hadn't seen a lot of, which Kyle Brown brought a lot into, which was cloud native storage. How do you do some of the different storage options? There's alternatives, there's trade-offs when you're doing a lot of that. And then when you're doing clients, and then ultimately, how are you implementing it? Is it you can still deploy on the cloud in a monolith, and the monolith is not an anti-pattern. It's actually the right solution most of the time, I would say. And I've even got a good story from some people at an architect at eBay. He uses a pretty high number. He says 90% of your application should not be microservices, you know, because it's got all the hype, but everybody wants to do microservices, but it's very challenging. But if you are doing microservices, it's important. Design is even more critical with microservices than monolith. Design's always important, but it even becomes more important because you don't want to have a distributed mess, a distributed ball of mud. And then quite often you're doing event-driven. Event-driven's become very popular today. It's been around a long time. In some of the patterns that were written originally a long time, 15 or 20 years ago for event-driven, but with microservices and with availability being such a key thing, that event-driven's become very popular, but it's also challenging. And so there's a lot of patterns related to that. And then ultimately we ended up with the final 2 chapters talking about application migration, modernization, and as well as quite often people have existing systems. And so how do they even move it to the cloud, or you want to move it to microservices, possibly on the cloud? And so that's kind of an overview of the book. There's no way in this hour that I have, whatever, that I can talk about all these patterns. There's way too many, right? But well, what I do is I have some potential, I can't describe all these, but I'll go over a few of them, and I'll go over a few of the chapters that I picked out that I to talk about today, and at least to give you a feel of it. And then depending on the time I can go over 2 or 3 chapters. I have enough material here to cover up to 2 or 3 chapters, depending on, or if we run out of time, I can skip and finish as well. And so if you're doing cloud applications, it's important to understand architecture. So that's why we started out with chapter 2 in our book. It is about application architecture. And although there's many architectural styles around, and for example, Garland and Shaw has a lot of architecture types of practices they talked about. You have patterns of software architecture by POSA. Whether you have many of these different types of architectural styles like pipes and filters, or whether you want to have a layered architecture or MVC, model view controller, and all these other types of things. But if you really look at a high level, you can really break most architectures down to really three types of architectures. And if you take a high level view of that, and so that's something that we covered in our book. So one of these three fundamental architectures is you can have one that I'm really known well for, which is the big ball of mud, or you're trying to do something. It's a monolithic. It's usually monolithic. It doesn't have to be. It could be a distributed muddy thing, but quite often monoliths might have this. And you're doing something quick and dirty, and so a little bit of mud isn't necessarily bad, but if it gets out of control, it can become what Brian Foote and I called a long time ago, over 25 years ago, is when we actually talked about the most successful architecture to date, big ball of mud. And then the second one is ultimately a good modular design, more like a modular. You can have a modular monolith, and actually very reasonable systems are like that. And if they're changing a lot, that could be the best design. And then ultimately, you might want to distribute some of those modules, maybe through microservices, but distributed architectures have been around for a long time, but maybe you want a certain part of it to scale differently. You might want to have a different team working and deploying parts of the architecture differently. And the first two architectures are generally monolith. But in fact, when you look at a distributed architecture, that's in a sense a modular. That's still modular. It's just you're distributing some of the modules, and you could think of a microservice in a way. It is a module in a way, and but if you really look from a high level, you're going to see this, and obviously there's going to be a lot of architectural patterns underneath all these different types of things that we're looking at. Now, there I am with my co-author, Big Ball of Mud, and lo and behold, this is still the most successful architecture deployed to date, even here in 2026. And Brian Foote and I wrote this up in 1998. It got published in one of the PLOP-D series, Pattern Language of Programs series, for that. And some of you may not realize, but that picture of the city design up there is of Brasilia. And Brasilia, like Washington, D.C., was a city by design. And just like most software systems, just like cities by design. So even though I've been to, actually 15 years after I published this paper, I ended up giving a keynote on Big Ball of Mud in Brasilia. I had no idea that would happen. So watch out what you write. All of a sudden you might be forecasting your future. So, and then I ended up in Brasilia, and it's kind of an interesting city. It kind of got that a little bit of the wing look with airplane, and it was designed by a very famous architect, and the Brazilian architect. On one hand, it's kind of interesting, but if you go to the city, the Brazilian architect that did a lot of the design of the city and the buildings was Oscar Niemeyer, and he's very well known. And but if you really look at Brasilia, even Washington D.C., which is a city by design, even when the city is designed, you still get urban decay, and there can be lots of problems happening. And here's even an example in Brasilia. Is you may in this picture here, if you look over to the right, that's their national library for Brazil, which is a pretty large country. They have, in fact, the largest Japanese population outside of Japan is in Brazil. And I went to that national library when I was there. Some people took me around. I was touring around, and I go into the library, and I was surprised. I'm in the National Library. Where are the books? And one of the things that they noted is the design of that building could not handle the weight of a lot of books. So if you put a lot of books in, it would collapse. And it reminded me of how many times have I seen software architectures where maybe, you know, there was this initial design and it looked like it'd be cool, but it couldn't handle everything that they had. Now, in all fairness to Oscar Niemeyer, maybe he was designing for the future, because now with ebooks and everything online, this building can handle a lot of that. But ultimately, what happens even in New York City, you'll see a lot of urban decay. You know, you're going to start seeing things start coming up, and once a city goes live, there's all kinds of forces that happen to it. And the same way it happens to software. And so you might ask, well, Joe, you published that big ball of mud thing with my colleague Brian Foote 20 some years ago. Is that still true? And not too long ago in the New York Times, by a technical writer, Lisa Polak there, she points out that still today, this still happens a lot. They call it technical debt. If you don't manage your technical debt, things get out of control. And so that's where this can still happen. And actually, a big ball of mud is not always an anti-pattern. A lot of times people call it an anti-pattern, like it's a bad thing. Mm-hmm. Sometimes you're doing an exploratory program, you're trying to learn. So sometimes doing something quick and dirty is exactly the right thing to do. In fact, if you're doing extreme programming or you're trying to go out there and experiment with something, you write it and okay, so what if it's a little dirty? It's not technical debt yet because we're still learning. And it's only if the idea takes off. In fact, Kent Beck talks about this with the 3X model, as you're exploring, expanding, and extract. If it takes off, that's when all of a sudden it can become a little bit of a problem. And that's just to point out, I was having a good discussion with my good friend Kiro-san, who's here today, is we were talking about a lot of times we've seen where people doing refactoring to patterns. If you don't really understand design well, just because I'm applying a pattern doesn't mean it's necessarily a good solution. It depends upon the context. And so Christopher Alexander, who influenced us a lot, talked about light on two sides. It's a very well-known pattern. So if I want a room to be very inviting, I'll have it so that you can get natural light on two sides. Families will want to be there. But if you're building a bank vault, you would not want to apply that pattern, right? You don't want to have light on two sides or multiple entries or any. So it all depends upon context. So sometimes you want to focus on features and functionality before getting the perfect architecture or performance or whatever, because you're really just trying to figure out and experiment and do this exploratory program. So sometimes this is exactly the right thing to do. The challenges happen. So this could be the simplest architecture for an application, and we can get something quick and dirty up and running to do the proof of concept. But then if it takes on a life, and then all of a sudden, then it can start to become technical debt. So a little bit of mud can be useful, even in buildings sometimes, or different things that they're doing. They use mud for making different things. It's not necessarily a bad thing, but if it gets out of control is where the problem happens. And so ultimately, a modular monolith, if you do start growing, you might want to refactor it and create some better modules with some better APIs and some interfaces with this. And it's a monolith, really a modular monolith, a monolith with different modules. And in fact, since you're not dealing with distributed transactions, this actually has a lot of benefits over a distributed architecture. Doing a distributed system is very, very challenging. And in fact, this is where in our big ball of mud paper, Brian Foote and I were talking about ultimately as you're going along is you find shearing layers, you separate things that change from things that don't change. And so they can live together, things that change together and do their own modules with this. And it's just like a building. In this building, you know, when they do the electric or the plumbing, that's kind of done separately from the lighting. And this room, the way they have it laid out, they can easily make a lot of changes into this room more easily. But if you have to do the plumbing, that could cause quite a problem. So you want to kind of things that change fastly versus things that change slowly. you want to do that separation of concerns. And so finding those different boundaries are important. And this becomes even more important as you evolve your architecture. So as a modular monolith, it's more like a single executable. Actually, before microservices, they didn't have the term monolith. The term monolith appeared when all of a sudden microservices, so what do we call things that are not microservices? So, even though it was the system, it was they didn't really have the term monolith, but now they look at monolith as if you're kind of deploying everything all as this one big thing, and it kind of all lives together. Even though you may have a few distributed things, it's still all deployed together with the database changes and everything else. And then ultimately, you have distributed architectures. And so if you have parts of your system that you want to be able to deploy and grow and change independently of other parts, you can separate that and deploy it independently, and it can be, it could even live in its own space out there on the cloud. So that's a distributed architecture. And here you're creating a composite application. It's a collection of modules, but they're each designed to run separately in their own process. And they can be deployed and scaled up independent without affecting other parts of the system. So the real problem here is you're trying to architecture applications so parts of it can be developed, deployed, and run independently. Now, if you look at our book, you'll actually see this one picture here. And though it can be a little bit deceptive with this picture. So design is always about trade-offs, and there's not always an evolution. Sometimes you say, oh, you start with a big ball of mud, and then you go to a modular monolith, and then you go to a distributed architecture. Sometimes that happens, but I've seen a distributed architecture all of a sudden become very muddy. And I've also seen distributed systems that were too complicated. Netflix has a good example where the performance wasn't working well, so they brought it back to a modular monolith, parts of it. There's still some distributed parts, but parts of it they brought back because there's always trade-offs. The ball of mud, probably the big, is when it starts becoming a problem. Ball of mud itself is not necessarily bad. Doing something quick and dirty and learning, and then maybe rewriting it 3 times is kind of the pattern that Kiro-san was talking about. Is do it 3 times, I guess is what he would call it, because then as you're learning, then you kind of get the right way to kind of do that. And then you might figure out what the right modules are, and then figure out if you need to distribute it. But quite often you are going to see a little bit of evolution. You start off with something that you're experimenting and learning with, and then the idea goes viral and it's value for your organization or your company or your university or your research that you're doing. Then you might want to clean it up. And quite often that monolith is really the best way to go, quite often. And in fact, the monolith itself, and this is kind of, for me, this is kind of a cool picture. Sometimes monoliths can look very cool. Sometimes they can look very appealing with that. And when starting, sometimes a monolith is the right solution. And it's not an anti-pattern. It's not something you want to definitely hide from. The problem is sometimes they get a bad rap. It's called legacy. It's called ball of mud automatically, but it may not be. I've seen some very well-designed monolith architecture. And in fact, I claim that most systems should be monolith and people should start off with monolith. It's a mistake to start off and try to build a distributed architecture. Maybe it's just a team of a few people building a big distributed architecture. Why do that when we can just build things working together and deploy it all as one thing? And it's easier to debug. Security is a lot easier. Cross-cutting concerns are easier to deal with. Technical debt is easier to deal with that. So it's not an anti-pattern. Sometimes you might just need to evolve the technology stack or the practices that you're doing. Maybe you get some automation or improve the pipeline, modularize the system a little bit better, working with some of your teams. Though sometimes if your system's changing a lot, you might need to think about doing microservices. So I've worked for a few different organizations that the monolith gave them a lot of success. But then once the organization really started taking off and they went from 20 some teams to hundreds of teams to many changes going on, and all of a sudden they had a good problem, but it was a problem of success where they were constantly customer base growing, all kinds of new features. There was challenges with that. So they had to really think about changing the way they were doing their architecture. So if you have a large number of teams and you're doing a lot of rapid growth, and if you have the right culture, and you better be doing DevOps for sure if you're going to be successful with microservices, and you have the right tooling and infrastructure, you have to be the right size to get the benefits of microservices, because there's a lot of costs and challenges with doing a distributed architecture. So if these types of forces are going on, then there's a lot of benefits for doing that. And so one of our chapters in the book, and I'll go over a few of these patterns from this, is we talk about if you're doing a cloud architecture, quite often, if your organization's large and growing and changing a lot, and you meet some of these, if you're the right size and you have a lot of these things, you large number of teams and a lot of things are changing rapidly, and you need things to evolve independently, you can get the benefits of that. And so that's where microservices come in, and microservices really took off around a decade ago, a little more than a decade ago. And this is a definition by Jim Lewis and Martin Fowler that they put out when kind of one of the somewhat approved definition of what is a microservices. I remember 5 years earlier when people were experimenting with microservices. What is it? Is it 100 lines of code, or what do we mean by microservices, right? But I kind of like this definition that they put out. It's an architectural style. It's a way of developing an application, just like a layered architecture, or or if you're using pipes and filters, or you're doing a meta architecture. This is an architecture style. And what's key to it is a suite of small independent services that run on their own process. They're communicating with a lightweight service, usually HTTP resource API, and they're really built around the domain, the business capabilities, and they can be deployed independently with a lot of automated machinery. And so if you really look at that, I mean, there's many variations. You could release a lot of your microservices on the same server, or you can go out on the cloud and deploy these into a lot of different places. The microservice style dictates that the deployment unit should contain only one service or just a few cohesive set of related services within that deployment unit. And it's really modeled around the domain, and the deployment constraint is a distinguishing factor. And that's how a lot of times you can tell. I work a lot with industry, plus I've done a graduate course at University of Sao Paulo, a master's course. And one of the examples I use is we'll look at some microservices, and we'll look at some code, and is this microservices or not? And they can't tell until you see how all those services are being deployed or not. Is it just one monolith thing, but it's been developed with a lot of services running together, or are they being deployed independently? And so that independent deployability is an important constraint. So since not only with patterns, but anything about design, there's always trade-offs. And it's important to discuss a lot of the different trade-offs. In microservices, just like there's a lot of benefits to a monolith system versus the fact that it's easier to debug, it's easier to test, it's easier to deal with security and cross-cutting concerns. Microservices have some different benefits as well. Smaller, more modular. It's easier to scale. It's easier to change parts of it. And it's easy to deploy independently units. Now, once again, you have a lot of services, so you still have to deal with that. Potentially it's less coupling if you design it right. You can still have a lot of coupling, you know, if you have dependency between your microservices, but that's considered usually some bad practices. So if you're doing microservices architecture, and that's why we, in our book, we talk about there's important design principles for when you're designing microservices, and a lot of people in the cloud are doing this. So it's important to understand. And each independent microservice is easy to build, test, and deploy an independent one. Now, it may be harder to, you know, there are some challenges though too, because testing can still be hard if you have a lot of microservices. You have to test the whole system. Testing my independent microservice can be very easy, but testing how they all kind of work together and are they still doing the job right, and debugging. Also, you have a lot of cross-cutting concerns. What about security? You know, so I have to deal with security across a lot of different distributed pieces. And, you know, I'm only as strong as the weakest link. So it does no, I could have the front door barred, but if my back door is open and it's easy to get in through a window or something like that, it's no good. And also the complexity level can go way up because now we have this distributed individual microservices, the complexity is simple. But all the I've worked with organizations that have thousands of microservices working together, sometimes tens of thousands, to get the job done. So you have different distributed transactions. Maybe you have multiple databases and you have to make them consistent. So there's a lot of these different types of challenges that you have to be aware of when you're dealing with this. So it's important to understand, and that's with any kind of design, or that's why most patterns always talk about trade-offs. And you get some benefits, but there's also some challenges or some costs that you need to be aware of. And sometimes if you are aware of it and you want to get the benefits and you have the need to get the benefits of doing microservices, it's important to understand the challenges so you can deal with the challenges appropriately. Oh, by the way, continuous delivery is very key. If you're going to have success with microservices, otherwise it becomes a nightmare. So having good tooling. So how packages are deployed directly affects different quality attributes, such as scalability, availability, reliability, security. And there's generally two architectural styles that you have the monolith or the microservices. And both are reasonable, and you want to choose, and sometimes you might have a hybrid approach. Parts of the system is monolithic, but we've broken off another part of the subsystem, and we're going to have some distributed architecture handle that piece, and because it makes sense for the types of systems that we're developing. So what I want to do is I want to move into, partly what I'm trying to motivate you with is when you're doing cloud, you're doing a lot of different types, you have many different types of architectures that you can do. You can actually put your whole monolithic system on the cloud. And we talk about a lot of patterns in migration or modernization for doing that. On the other hand, if you're doing microservices, it's important to understand good design principles. And design principles have been around for a long time. A lot of people have probably know from if you're doing reusable object-oriented systems and you're working with design patterns, Michael Feathers and Uncle Bob talked about the solid principles, where you have the single responsibility or the open close. Open close I always like, and it kind of fits with microservices too. And open close actually, Bertram Meyer put that out originally, and then the solid was actually coined by Michael Feathers working with Uncle Bob, but Michael Feathers came with the acronym, and then Uncle Bob put it in his book a long time ago, over 20 years ago. But open close really means it's open for extension, but but closed for modification. You're like, huh? What does that mean? Or at least for me, when I think of it, what does it mean? It can sound confusing, but what it really means is this. Wouldn't it be cool if you have to add a new feature and you don't change any existing code? You know you didn't break anything. So if you have a way of you're able to write something new for the new feature, but you didn't, and that's real. And so black box frameworks were like this, or if you have DSL or you know, a kind of a good meta architecture for doing that. You have some ways of describing where you can put sometimes with a design pattern, maybe you have like a new strategy and you can plug a new strategy in to get this new type of rule behavior without changing any of the existing code. And there's a lot of benefits. And the Liskov, she's a very famous computer scientist from 50 years ago or more. But she wrote this very famous paper about how types and subtypes have to work well. And then interface segregation is we're really trying to break. To me, interface segregation is almost like the single responsibility on the APIs, is another way of looking at it. And then dependency inversion. So these solid principles have been around. And so solid works well for object-oriented design. And then we have design patterns, and we have these other principles about dry, don't repeat yourself, or keep it simple, you know, and or Yagni. I don't know if people have heard of Yagni. You aren't going to need it, or sometimes people say you ain't going to need it if you're using slang with that. But what about microservices? You know, what if I'm developing microservices? You know, what are good design principles? And so we need some ideals for designing microservices. So in chapter 5 of the book, this book over here, I'll grab it again here if you don't mind. Thank you. So in chapter 5 of this book, we start off that if you're doing microservices design, it's important to think about to understand what are some good design principles. And so with my good friend in Brazil, and here we are at the Golden Coxinha place. Coxinha is a very famous kind of thing that you eat in Brazil, and all the different cities are all who has the best coxinha. It's kind of a fun competition depending on. So, but we put together these when we were out there working with people with microservices as they were going out, like from 2015 to 2020, people would ask, well, how do the solid principles, do they apply to microservices? And so we came up with our own acronym, and partly as we wanted to make sure it said a word. So we had ideas, but with a little bit of feedback. And even here in Europe and Japan, when I came to Japan, Hiro even helped me evolve it. We evolved it to ideals. And so these are kind of some design principles when you're designing microservices. And some of the principles from the solid still make sense. But if you're doing microservices, it's important to think about some of these principles. So interface segregation is still very important. The API to your microservice and how you do the separation of concern for that. Deployability is always important, but it becomes even more important with microservices because you're deploying a lot of pieces together. Event-driven microservices have definitely pushed the limits on event-driven. That becomes a very critical design principle. And then availability over consistency. And it doesn't mean you're going to be inconsistent, but it's over eventual consistency is what we really mean there. And then coupling is always an important software principle, but it becomes even more important when you're building many distributed pieces, because there's nothing worse than having a lot of coupling between a lot of different distributed pieces, because that's kind of a maintenance nightmare, and it's like a distributed ball of mud. It's very worse. And then single responsibility is still applicable here, and it becomes even more important when you're dealing with distributed architecture. And so, just to kind of go over some of these ideals, if you really look at the original from Uncle Bob with that in his 20 years ago book, and Agile Principles, Patterns, and Practices in C# is where he really brought this up from the ISP principle description. This principle, it really deals with the disadvantages of trying to have a fat interfaces. In fact, sometimes you're better to have fold-out interfaces or multiple interfaces, depending upon the types of clients. And so what you do is you want to group your related set of responsibilities into the different interfaces so that way I don't have to worry about people that are using this type of system, they don't have to understand all the different types of variations of it. They only have to understand what they need to know about it. And that's a big benefit of that. But with microservices, services are also called by a lot of different types of clients. And you might even have, you might have web applications or backend services or mobile apps. And originally, what service-oriented architecture did before microservices took off is they had more of this canonical model. And so what we're really trying to do is we're splitting your interfaces to manage dependencies well, and similar to like the single responsibility principle based upon the interfaces. And today, each client should see a service contract that best suits its need rather than trying to apply, before they were trying to do this enterprise architecture with SOA about 15 to 20 years ago, the mid 2000s, was service oriented architecture was popular. And then you would buy a lot of these type of platforms, either like from IBM or Microsoft or whatever. And there you had to kind of stick to this canonical enterprise interface. But in the real, that meant that I had to understand a lot about other parts of the system that I didn't need to understand. And so by splitting this out, then I can just stay focused. So you might say, how do you do that? Well, fortunately, there's a lot of patterns. And so one of the patterns that we put in our book to describe this is we call it a dispatcher. And this is like, some people you'll hear call it, by the way, that's a QR code to the book once again, is and I will say at the end of this talk, I'll give you a QR code to all these materials so people can download all the materials they have, the slides or everything that we're talking about today. But quite often you hear people build an API gateway, and you might, for example, you might have a way that you might have security controls for doing different types of things depending upon the different types of client that's coming in. And so your dispatcher might also have to be doing some delegation between some other microservices on the back end. And this is actually a variation of the design patterns, proxy and adapter kind of pattern with this. Okay. Yes. Another. This is very common that you're going to see in. You hate what? The design patterns. The design patterns in general.
I hate the dispatcher.
The dispatcher. So, yes, but sometimes you need to delegate. You don't want to. So the advantage of that, and actually Rebecca Wurzbach and I did something for sustainable architecture patterns, is sometimes you don't want to muddy up the component piece with all the different interfaces, and you don't want to muddy up these two, because now you're highly entangling the client with the wrong thing. So then you put this uglier piece in the middle, a mediator. Sometimes a mediator is another example from the design patterns that do something like that, as this dispatcher. And sometimes these dispatchers act like BFFs. So you might want to say, I'm going to have something different for the iPhone versus the Android versus the web app. And there might be backend systems that still need to interact from banking, for example. There could be something coming in from central bank that we have to report to. So we don't want to muddy up all these things and entangle them. So to remove that, and so trying to remove the dependencies, especially with distributed architecture, we create this layer, but it can be a little bit of, it's kind of where the ugly code goes to kind of glue the pieces together between these two. So you can keep these other two evolving independently with that. And so that's why they have this dispatcher type or this back end for front end type variation with this. If you look at Chris Richardson's book, he calls it the API gateway with that. But we were making it more generic because it can handle a lot. It can handle a little more than that, and it can do glue code as well. And that was one thing me and Rebecca Wurzbach were talking about with our sustainable architecture. Is you want to protect this part from this part, let them change independently. So then you work the interface thing that knows how to glue the two pieces together is handled through the dispatcher. You're better off if you don't need one, but sometimes you need one. But once again, there's trade-offs. So, and this is probably why Kiro-san, who said he hated it, it's got many challenges with it too, because the benefits, your services and clients can be more loosely coupled. That was a benefit I was talking about before. It insulates the clients from how the application is implemented, and then those teams can evolve and change that independently without affecting the clients. And also, if you have to talk to multiple services, you don't have to put that in the client. I was working with a large bank in Brazil, the largest Latin American bank, and one of the problems, because they have a super app, and so sometimes they need to talk to a lot of different services to get the work done. Well, if you put that in this middle thing, it can do some of that communicating between, and then based upon the business domain thing, it can kind of wrap all those up and then bring that back, and the client doesn't have to handle and know all that internal what's going on with those types of things. On the other hand, it's another evolving interconnected part. You have to increase complexity. You have the overhead of the extra network possibly. You have the maintenance and governance type things, and that can be quite a burden.
The reason I hate the dispatcher is that it's often used to hide the bad design of the hiding microservices. And then sometimes dispatcher can be a bad design as well. And then it ended up a dispatcher for dispatcher. And then you know what it breeds. It's a so many layer dispatchers, it creates a spaghetti already.
That's right. If you don't design it right, then the dispatcher can definitely have a lot of challenges, and that's why you need to know the complexities. It has benefits, but you have to use it properly, just like any design pattern or anything that you're doing. You know, if I'm using a layered architecture, but if I'm doing the layering wrong, it's just, and this is in a sense a kind of a layered type thing going on here with that as well. Now, deployability even becomes more important because it increases a lot the number of deployment units. And so good design and implementation don't get success. We still need good deployment strategies. And so automation is important, DevOps, your types of testing, you might have blue-green testing, a lot of other types of things. Making things visible so we see what's going on, containerization. So there's a lot of other types of principles that help with this. So that's what the D was for. Now the E in event-driven is, hey, by the way, synchronous calls are still around and they're still here, but there's a lot of challenges. Today's scalability and performance, if I'm going online and I'm going to Rakuten and I want to do an order, I won't put up with it waiting for very long. I'll go somewhere else or do something. And so it poses a challenge. And so a lot of times people are pushing for events to be done asynchronously. And so if you look at chapter 6 in our book, we have all these patterns for dealing with event. And you look, are you doing orchestration? That we have a set of patterns in the microservices of that. And SOA was more on orchestration. Or are you doing event choreography? And there's trade-offs, once again, on choreography versus orchestration. But there's definitely a lot of benefits too. And if you have the right business case for it or the right need for it, for the system you're designing, doing an event-driven system makes sense. And so actually this has been around a long time, EDA. It's an architectural style that was done a long time ago. And where you do a pub sub model with this. And it was published in the enterprise architecture patterns a long time ago. And for microservices, the event bus is usually part of your infrastructure with what's being used here. And so here's an example. So when I flew here to Japan, you could think maybe I wanted to use mileage. You know, I have a lot of points. I fly a lot, so I have a lot of points. Maybe I want to use mileage. And then so I decide I want to submit an award request, and then I create a booking, you know, so I want to create an award booking. Ultimately, I try to make a booking, and then I have to notify the FAA, and then ultimately email the passenger or something before the system's done. Now, what happens if one of these pieces is down and not working? If that case, the whole system kind of goes down until you say the FAA is down at this point. So an alternative would be, and this helps with availability, is instead, I'm going to submit a ward travel request, and then it returns back, okay. Usually you get an email that's saying, oh, an award travel request has been done. Once we do your booking, we'll let you know once we've confirmed your ticket with everything. And then it tries to make sure I have enough miles and get me a booking created. And then ultimately, as it's going through here, I can actually do the booking. Now, imagine if the FAA is down, the system can keep going. It can keep the events, and then ultimately, once the FAA system comes back up, which could probably a third-party system, one that we're not using, we have to actually report to the FAA and make sure everything's okay. And at that point, then we can queue up all those events and then process those events. And then ultimately, once a booking's created, it can do the final email with that. In the meantime, the system is able to kind of stay up and help with availability. Even if part of the system goes down, it can still handle something. So that's one of the benefits that you sometimes see with this event driven. But once again, there's benefits, right? Publisher and subscribers are independent. They're more loosely coupled. I can add the publishers don't even have to know about the subscribers. Think of the booking system. We were doing emails. What happens? Maybe we want to add an SMS, or maybe we want to add, we want to send a message through Line or whatever for that. We could just write a new type of thing that subscribes to that event that the booking was created, and then sends you a message, and we maybe have a configuration saying which way should this customer receive the messages, through email or through a notification to the app, or maybe it's through an SMS type messaging. So there's more flexibility to add functions by simply adding subscribers to the events. The publishers are not blocked. Events can be consumed with multiple subscribers in parallel. If one goes down, temporary failures in one are less likely to affect the others. There still may be dependencies that wait on them, but on the other hand, the other parts of the system can still continue on. On the other hand, you still have to maintain, there's more moving parts, debugging and event driven. The user interface has to be handled differently. Fortunately, there's a lot of good patterns to help with that. Security, you have to, because now you have all these events going around with different parts of the system, and maybe it's distributed on parts of the system are running on another system. So understanding these is important. And then the A is availability over consistency. And so the CAP theorem, and the CAP theorem's been around for a long time. And really, the CAP theorem is an extension to the well-known PACELC theorem. What it's really talking about in distributed computing systems, when you're partitioning up a system on a distributed system, you have to choose between availability and consistency. You cannot guarantee both, and there's always trade-offs. If you wanted more availability, there's going to be a cost with consistency. Ultimately, you can still get consistency, but it's eventual consistency. But it's important to do that. But nowadays, people tend to favor this. Sometimes you still have to have guaranteed consistency. If you're taking money from my bank account to your bank account, I don't want anything to go wrong during that transaction. So I want guaranteed consistency through that. But on the other hand, a lot of times parts of the system can be a little bit inconsistent. You can even think like an online ordering system. So what if it's not quite updated with the exact inventory amount? We find out a little later, we may have to send a notice. Oh, sorry, we're out of stock on that. We're going to have to, delay the delivery on that. But ultimately, you have to have consistency. But a lot of times with parts of the system, you can deal with some, to increase availability, you can deal with some delayed consistency with this. So generally, whenever you're thinking about availability over consistency, you tend to favor availability whenever and wherever you can nowadays within that. But you have to understand the trade-offs with that once again. And in fact, Bertram Meyer, who did he did command query segregation, But what really with CQRS, which is a well-known pattern, it's saying separate the reads from the writes. And so then you, most of the time, with a lot of online systems, and this isn't always true, but that way you can scale up and the two parts can vary independently. And if you need to really scale up the reads, you can do that. And so this is one way to help out with availability. And there's very many variations. You could do it in the same process for doing that. But a lot of times, like when I'm going on with a system, you think of an online ordering system again. I'm doing a lot of reads before I place an order. I'm looking, I'm shopping, adding to the cart. Now I place the order and there's a write, But meanwhile, I've had to do a lot of reads with that. So being able to separate that, and you have a lot of people hitting it at the same time, is you can separate that. And here's a good variation. You can also do things like database per microservice. There's a store and forward. There's a lot of other patterns that can really help you with availability over consistency. Here's a store and forward, and circuit breaker is another one. If something goes wrong and it's not available, you can still hang on and find out once that's available again. You're queuing up all those responses and then doing it, and it helps with reliability. So that a lot of these good, well-known patterns can help with the A for availability. And then finally, then you have L in the ideal. So type coupling is always, we always try to have high cohesion and low coupling, right? In any kind of architecture. And this becomes even more critical when you have like a runtime dependencies with a distributed architecture. And by the way, this picture that you're seeing here is the picture of a real system with many microservices and many databases. I'll leave unnamed the organization that I was working with with that. And actually, it's gotten a lot bigger since then. This was quite a few years ago. But, so if there's a lot of dependencies with that, and if you notice something with that picture, you notice there's a lot of dependencies more towards even the middle part of that, which is a certain part of the transaction. And this is a financial domain where it's the kind of the equivalent of doing something like PayPal and Square equivalent kind of. That's a company with something kind of like the equivalent of that in some other country with that. And as they evolved to the microservices, there became a lot of dependencies. So you got to be careful with that. And so dealing with coupling is always an issue, but it even becomes more critical to reduce that runtime coupling. But you might ask, how can I do this? Fortunately, there's a lot of other well-known patterns that can help with that. And that's where you model around the domain, thinking about separations of concerns, and then you carefully design the contract. And then there's a lot of wrapper. This is back where some of the wrapper patterns, or even if you're doing event driven, can help, and even the dispatcher, BFFs, and things like that can potentially kind of help you with that. And that's why you have these protected components. You may have this. Rebecca and I, one of our patterns, we talked about this front door wrapper would wipe your feet before you come in. So take off your shoes before you come into the house, right? So same way here is, and so this is the place where you can do that, and it can handle the cleansing and how things have to kind of communicate to better. That way, the different services can be more independently and evolve a little bit better. So there are some patterns that can help with that. Things like asynchronous messaging, event-driven, API gateway, database per microservice pattern is a way of you can kind of do that. So now I'm not, because by the way, you build a distributed architecture, and if we're using a single database, now I'm dependent on the database. And so that can be a lot of problems too. And that's why a lot of times there's trade-offs with that too. But one of the patterns is database per microservice. You don't always want to do that, because there's challenges with that as well. But because then you have distributed data and you have to resync that type of stuff. On the other hand, you're removing some of the dependencies, and you let these different types of when you model around the domain, you find the right bounded context. You can deal with some of this. And then finally, the last the last pattern for the S for the principle is single responsibility. So we have interface segregation, deployability, event-driven, availability over consistency, coupling, loose coupling, that's low coupling is important, and then single responsibility. And so similar to just like SRP with object-oriented, here we have like, you can think of subscribing to a service. Maybe it's going to be an online service for videos or articles, or maybe the New York Times or things like that. Well, if you look at this one here, it has things about payments. It has things about when it expires, whether it's inactive or not, whether you have discounts. And so it's better to separate that. And if microservice is packed with too many responsibilities, it can have the pains of the monolith. And if its responsibilities is too slim, you need to interact to fulfill a request. And you can have distributed transactions, and your data changes are spread across a lot of different microservices. And that's definitely a lot of problems too. So how can you apply this principle? Well, once again, size is key. You don't want to be too small, because if you do, I mean, with microservices, I could make every function a microservice, right? It wouldn't be a necessarily a good thing to do, but you really could. You know, idealistically, just like you could have a single database with like 7 tables with a lot of joins. It's not the right thing to do. But you know, it's so finding the right size is important, but you don't want to be too big, because you don't want to end up with what I call macroliths or mini monoliths, a distributed monolith, nothing worse than a distributed ball of mud. So you need to be careful there. So how big should they be? Size matters. And that's where good design principles, such as modeling around the domain, such as what Eric Evans talks about with domain-driven design, some of those principles are important. But by the way, Hiro, I just want to make sure how much time and how late are we going?
It's okay.
Okay. Okay, that's cool, because I have plenty of good material here. I just need to,
Sure.
like I said, I've covered a few different chapters here, give a feel, but I haven't gone into details.
Very informative, very,
Yeah.
very nice, thank you.
And by the way, just for everybody online and anybody here, is I will be back in Japan at the end of March for Asian Plop. And when I do that, I am available for doing more on this. I even have some accelerated master's course where I've done things with industry where we go into a lot of details on some of this. Because I mean, here where I'm really getting into what's the core of chapter 5 in our book. So ideals are the good design principles. If you're developing microservices, you need good design principles, or you have all the problems that Hiro-san was talking about. There's many challenges. You want to blindly just apply. People all of a sudden learn, oh, API gateway, let me just do it. And then all of a sudden you have an API gateway for the API gateway, and you know, and it starts getting out of control with that. But if you understand the benefits and the trade-offs, and if you're designing properly, you have to get to size is key. So domain modeling can help you come up with the right size. It's not in the terms of lines of code. It's in its functional scope or the business capabilities. That's what's key, is finding those boundaries. So single responsibility, well-defined microservices must have. That's where the S comes in. And then model around the domain you must. So, you know, this is kind of a key principle. It becomes even more key. And in fact, even with Agile, and whether you're doing Scrum or lean practices or whatever, one thing about domain modeling was still a part of Agile development. However, even this problem had approaches, because you had your domain experts with a development team, and the domain experts, even if you get real close, and sometimes that's a challenge, is making them close enough where they can communicate well. There were still many challenges, because the developer sometimes, or development team, acts as a translator. It's just like translating languages. They're translating what they understand from the domain expert into code. And then ultimately you have some kind of deliverable, and you have the feedback loop. And that's helpful. But as in any translation, there can be problems. There's always problems. Even with, I'm coming here in Japan and trying to translate as well as I can from Japanese to English and stuff. There still can be miscommunication or misunderstanding. Same way with the code. However, there's another approach. Even if you are doing Agile, what if the domain experts and the development team and other stakeholders and even the code, we start getting this shared mental model and we kind of start working together. And the code even reflects a shared mental model. Thus, even if when you bring in, maybe a domain expert leaves and you bring in a new domain expert, or a new developer comes in, since there's this shared mental model, they're looking at the code and there's this shared type thing. And that's really what was key with doing that. And by the way, you can do DDD, domain modeling, and DDD principles with functional programming, even though it was originally done with Eric Evans with object-oriented design, it still works well, even with functional programming. I got a little bit of the variation of this picture from that book, but having this shared mental model, the code reflects a shared mental model, and this is really the goal of DDD in finding the right boundaries and separation of concerns. And so that's really, if you look at Eric Evans' originally Blue Book, which by the way, just had celebrated 20 years a couple of years ago. I was there with Eric Evans. We had a cake at a big DDD conference, and we were figuring out whether it was a layered architecture or there was mud in there. He even had the big ball of mud pattern mentioned as one of the patterns, and anti-corruption layer, trying to set a separation of concerns once again. Then the dispatchers help with that. But once again, is there corruption in the anti-corruption layer?
Yeah, you know, the enterprise system that 80% of the code is actually anti-corruption.
Yeah, it very well.
Domain.
And by the way, language, corruption has a big different meaning in Brazil, in Portuguese. So when you look at, so when they were explaining even the word corruption, it has quite a different meaning from Brazil than what we're thinking about with software. So you have to even with language. And so even if you think of using AI, you might think, oh, can we prevent a lot of balls of mud with AI? What's it learn on? Most software and most things in the open source stuff out there are pretty muddy, and they have a lot of different problems. And so it can generate a lot of technical debt and a lot of security risk. So, but if you use AI right, and depending on what you feed it, once again, that's important to know what good design is.
It's largest mud, right?
Yes, that's right. That's right. And so chapter 5 in our book, besides talking about these design principles, the ideals that I did, we talk about modeling around the domain. And so you get to stakeholders and you try to use some lightweight things to describe the subject area in terms of the domain that you're modeling and come up with a shared vocabulary. The ubiquitous language is what Eric Evans calls it. And I probably don't want to go over all these patterns, but I want to give you a feel of a couple of these before I wrap up for today, because I could go as late as people want, but I know people have time constraints with this. But just to give you a feel, in this chapter, this is kind of a mini pattern language about modeling. You model using domain concepts of the ubiquitous language. Event storming helps you do that, helps you drive to that. Event storming was developed by Albert Brandolini in 2012 as a lightweight mechanism for getting the domain experts with the technical people together and talking about doing this. You talk about the different types of things that happen with the system over time. Usually you do it on a whiteboard, though sometimes you can do it on online systems such as Mural or whatever, and with online stickies. Though it works better in person if you can, though when we went to the pandemic, obviously we all had to do it online. And then you start grouping a set of these events, finding the boundaries between them, the bounded context. And really within this event, when an event happens, you try to see what are the types of things that you have, and when this event happens, what are the types of things that you need for it? So your aggregates are like your entities and your values and your attributes for that. And then ultimately you want to protect different bounded contexts, the different types of subsystems and subdomains as they evolve. So that's where the anti-corruption layer. So Eric Evans' books had many, many of patterns, but really what I have found, if you even use a subset of some of these domain modeling, you can get a lot of benefits. You don't have to do all this, even from a high level, you can do some of these lightweight things, such as an event storming, it's a deliberate collective learning. By the way, I will say that me and my colleague friend Martin Newberg used AI to generate some of this art from the picture, the caricature of Albert Brandolini from a lot of things. So AI can be good for some graphic stuff, I guess. But I don't want to go over the details, but really what's going on is your event forming session, you have these different types of things with these color stickies that you use over time. And you identify the sequence of domain events over, usually in English anyway, you go from left to right. Here in Japan, maybe you'd go from right to left. I don't know, over time, depending on how you wanted to do it. And then you add the commands that cause the events. You figure out what the actor is, which could be a human being, or it could be an external system that triggers the command. And then you add what are the types of entities and values we need with it. And then what are bounded contexts around these pivotal events. And the example I use, because I like pizza, and we had Joe's Pizza with ordering a pizza. You can think, oh, well, maybe I'm creating a new pizza shop here. And I'm going to serve up some of the students here at Waseda University here. And me and Kiro are going to do it down here. We're going to write an ordering system for it. Well, we have a customer and they want to, that's one of the order requested. Then we have they need to enter in the type of pizza, and these are always done in past tense. So what are the types of things that happen in the past? And the payment was entered and the customer address, and then ultimately the order was placed. And then the team decides on the legends of colors, but there's some kind of standard colors most people use with this. I put up some suggested colors that you see if you look out there online. These are the common colors you see. And then ultimately, after you place the order, then you might need to prepare the pizza, and then we might even want to deliver it. And we have different boundaries within that bounded context, and we have separations of concerns. So we can have different subsystems that can develop independently, and those can evolve independently. And then ultimately this is going to map to code, right? To different entities and value objects is what's gone. And then the anti-corruption layer is really what me and Brian Foote were even calling this in our big ball of mud paper, shearing layers. You're trying to separate what parts of the system changes from the other part. So you don't tear up the other part. Just like the electrical here, you want to have separated from the different walls. Sometimes you might have walls that move, or you can do different lighting or things in this room. Ultimately, you're going to map it to microservices, and I just want to I'll finish with this and then wrap up. Is ultimately all these bounded contexts become a microservice when you actually implement this. They do. And if not, you have subdomain, then you make a smaller bounded context. So you could have a bigger subdomain. Credit card might have a few things in there, but ultimately for all your aggregates, you might have a domain event and things that go on, domain services, your repository will map down into that. You might be talking directly to another bounded context, or you might be publishing something on an event. But I won't go through all the details. But if you do look at the book, you can see a lot of the details in the book for that. The cool thing about this, and by the way, this is from this Pattern Principles and Practice. This is a great book if you want to learn domain-driven design, by the way. But if you want to learn a subset for doing microservices, I'll recommend this book. But in this, Millett and Toon, Nick Toon and Scott Millett, they talk about that domain modeling, whether you're doing microservices or not, leads to kind of a layered design. Because here you have, and with microservices, you have the application layer. Here's your entities, VOs, and domain events. So layered architecture has been around for a long time. And Garland and Shaw talked about it over 30 years ago in their famous software architecture book. It was definitely in the POSA book. And then ultimately you have your persistent layer. Now, I'm gonna skip this part because this is just, I do have another chapter in the book that if you have a monolith and you want to go to microservices, there's another pattern language that can lead you. I'll just show you to call strangle the monolith. And Martin, this is kind of off a coin that Martin Fowler talked about before microservices and before there was things called monoliths. He called the strangler application. You have a system and it's kind of muddy and hard to change. And so you strangle out part of the old system by replacing it with a new system. And
Strangle is a little bit too strong words. Martin Fowler asked the people to use to strangle a fig.
he called it the strangler fig. Yes, we call it strangle the monolith because you really do want to strangle. You want the parts of the monolith to die. So we decided to go ahead and stay with that. And actually, originally he called it the strangler, and then he called it the strangler fig because he used it because you could even think of these trees. These are in Brazil a lot. There's different places in Australia where the parts of the tree grows off of the other tree, eating out, taking over, but it is actually killing ultimately the inside part overall with this. So here with strangling the monolith, you might wrap it to protect from change. Sometimes you write any new features as a microservice so you don't add to the mess, and then you ultimately may find hairline cracks. That's one thing that it's similar to what Michael Feathers talks about with working effectively with legacy code. And you find places in the monolith where you can extract out components, or sometimes it's such a mess you can't do that. You have to refactor then extract. Sometimes it's so bad you can't even do that. You have to completely replace the piece. And then you might have to have a monolith to microservice proxy because pieces are talking through. Now, I won't go through. I have a lot of scenarios. I'm going to skip these. And there's a lot of patterns with sequences. I just want to kind of point out that with this organization that I worked with, the equivalent of PayPal and Square, they were Paxaguru, they were growing rapidly. Ultimately, they were doing Scrum. They had 20 some teams. Every week, 1/4 of the teams could release. So that means you release once a month, but you would develop for 3 weeks and you had the integration hell week putting things together. But so you could, they were, they even had a famous paper that they released for, they called it Mega Scrum, that they did at one of the early Agile conferences in 2010. And they were showing how they were scaled up to kind of work as the teams growing up. But once they went to microservices, it got a lot more lean and agile for doing new types of features. So this is even before the pandemic. One day before, you could only release every 4 weeks and accept emergency type patches or stuff like that. Now they were literally having hundreds of little small things they could experiment with and release, including new features, configuration changes. It was impossible before. And so depending on what's going on with your organization, and imagine when they went down from 20 some teams to hundreds of teams, trying to release and manage that monolith and integrating all those pieces, it became very challenging. And a lot of organizations are doing this. So anyway, I showed you a few of these chapters. I gave you a little bit of the application architecture, and then I gave you a little bit of a feel of what some of the chapter 4 and 5 and a little bit with 6. I gave you a little bit of feel. I didn't go into all the details with the orchestration, versus choreography. I probably spent more time on the design because I love design. And to me, if you're going to have benefits of any of those other architecture, design is critical, and understanding good design for patterns is critical, and knowing your domain and understanding what good architecture is key. So that's why I spent time. So AI can help. By the way, with this QR code here, you can get a podcast of me and Martin, where we used AI to help do some domain modeling. Is because nowadays you can record people and you can give the stickies and take pictures of the stickies, and it can help. You can we have certain prompts, and we even have open source available of our prompts and how we played around with it and things have changed a lot. We did this 6 months ago. You know how much things have changed in the last 6 months with AI. So AI can help. See what happened. Something happened. Something happened. I mean, oh,
Yeah, it's
okay. And so just to give you a feel, bounded context and bound, and ubiquitous language are just important with AI. So here we have a domain with this. And so next week, Hero is organizing this event, AI Patterns in Tokyo. And if you want to see more about what's going on with this, and then also Hero and I are both involved with at the end of next month, where I will be back if anybody wants. And if we want to organize any other types where we can go into more detail with some of this is patterns. And in fact, the patterns on the bank with agentic enterprise agentic design, thinking bounded context and ubiquitous language can map well to help you be more successful with getting because context is key and making sure we're building the right and providing the right knowledge for the types of systems that we're building with this. But I'll have a little bit. I just wanted to give a teaser for next week so people know about that. So anyway, pause points help. Slack time's important. And in fact, we didn't have much Slack time for this session, but in fact, Hero was part of influencing Hero and me and Adamar. We even wrote this up as a pattern. It's important to have Slack time, even with AI, to do it right. So hopefully, I don't care whether you're doing DDD or not. I don't care whether you're doing microservices or sometimes it's the better thing to do. Even talk with people, large organizations, most of your systems should be monolithic, not microservices. But when you do, it's important to whether you're doing microservices or not, modeling around the business capabilities of the domain. And you can use a subset of some of those domain modeling concepts to get a big benefit. And there were some guiding ideals that I presented. And so applying these guiding ideals for microservices can be helpful in finding the right size and the right boundaries. And that's where bounded context can help you find the right boundaries within this for sustainable development. And of course, we still want to learn with this. So there's a lot of other books talking that are important. DevOps, if you're going to, there's Von Vernon does a very good book on domain-driven design distilled. Sam Newman has a pretty good book if you're building microservices. Chris Richardson as well, if you're focusing on all that. And so anyway, that was most of what I had. I just want to emphasize once again, there's my information. If you want to reach out to me for anything on this, you can. The slides are on that QR code right there. Everything that I showed you, you can find. And these are two quotes from the bottom one. If you think good architecture is expensive, try bad architecture. That's a quote by me and Brian Foote out of our Big Ball of Mud paper. And it's still true today. If bad architecture is much more expensive than good architecture, even though sometimes people think, oh, we're spending too much, let's do something quick and dirty. And also, the second quote is from our Agile Quality papers that I worked with Hero. You can't fix it. So we have quality radiators and other things. So you can't fix what you can't see. So it's important to have different types of radiators. Even Alistair Coburn puts out information radiators are key. And so I'm just guessing. So it's important for me to have some kind of feedback. Otherwise, who knows what I fixed. So thank you very much, Hero, once again for organizing everything. And I hope to see some people next week if they get a chance. And also in Asian Plot, or when I come back, I'll come a few extra days if we want to organize any kind of event with that. So thank you.